The last thing we're going to discuss now is the chemical reactivity of alkanes. So alkanes are fairly inert towards most reagent. And alkanes are inert because all the bonds you can find in alkane are sigma bond. And these bonds are between carbon and carbon or carbon and hydrogen. And these bonds are very strong bonds. They are very difficult to break. There is no difference in the electronegativity between the two atoms, carbon and hydrogen, and of course, carbon and carbon, they both all carbon atoms have the same electronegativity. So there is no tendency of any of these atoms to attract the electrons towards it. This is why the bond between carbon and hydrogen or carbon and carbon, the sigma bond, is very difficult to break. We need very high energy to break this bond. And to take part in any chemical reaction, you need a bond that is easily broken. And these bonds are not easily broken. So you will only find chemical reactions of alkane, very few chemical reactions of alkanes, and they will usually need very high energy to take place. So one of these examples are the radical chain reaction of alkanes. An example of that is the photochemical chlorination of an alkane. So to start this reaction, it's a reaction between chlorine molecule and the alkane to give you a photochemical reaction. So what will happen is that we start off with the chlorine atom, the chlorine molecule. So chlorine is two chloride atoms attached to each other with a covalent bond with two electrons shared between the two chloride atoms. So when you subject this chlorine to a photochemical energy, ultraviolet light, high energy, they will start to break homolytically, which means that the bond here will break equally between the two chloride atoms, which means that these two electrons here will actually move one to each chloride atom. So you will end up with two chloride free radical, each will have only one electron. Normally for stability, any atom or any molecule needs to have all its electrons paired. So if it has electrons which are not paired, like in this case, it's called free radical and it's very reactive. So the very highly reactive chloride free radical will then be formed in the first stage of this reaction. The first stage is called the initiation. So we initiate the reaction by forming the free radical of chloride. Once this free radical is formed, it will start to do the second stage of the reaction, which is called the propagation. So propagation is basically when this free radical starts to react with the other species in the media, and it will form other free radicals. So the chloride free radical can react with the alkane to give hydrogen chloride. It will subtract one hydrogen with one electron from the alkane, and it will give hydrogen chloride and a free radical, alkyl free radical here. This alkyl free radical now can also react with another chlorine molecule to give alkyl chloride and another chloride free radical. This step will continue until all the species in the medium will be free radicals. No species will remain as a compound. So when there is everything there is a free radical, then the final stage of the reaction will take place, which is the termination. So all the remaining free radical in the reaction medium will react with each other to give you different species, a new species or different molecules. So if two chloride free radical react with each other, they will give you chlorine molecule. If a chloride free radical react with alkyl free radical, it will give you alkyl chloride. And if two alkyl free radical react with each other, they will give you a new alkane. And also they can react with each other because they react in so many different ways because they are very reactive. So it can give you an alkene and again an alkane. So this reaction will result in a huge number of products, all because of the very high reactivity of the free radical. Another type of reaction you can find with alkane is a combustion. And we know that combustion is burning of alkane. Combustion is in general is burning in presence of oxygen. So for alkanes, it will be burning of the alkane in presence of oxygen. So there will be a reaction between the alkane and the oxygen to give carbon dioxide and water. So the simplest example here will be methane. So methane reacts with oxygen to give carbon dioxide and water. This is the overall reaction. But first, to make this combination, to start this reaction, we will need some activation energy. So we start with the energy of the reactants, which is the methane and oxygen, and then we need some activation energy. We need heat to initiate the reaction, and then we go to a transition state where there is a very high energy here, and then once the products are formed, the products here will have much lower energy than the start or than the reactant. So the delta H, which is the enthalpy of the reaction, is the difference in the energy of the product and the reactant. So if the products have lower energy than the reactants, such as in this case, then the delta H will have a negative sign, because delta H is the energy of the product and minus the energy of the reactants. So the energy of the reactants here is higher than the products. So this is an exothermic reaction. If it's the other way around, it's going to be an endothermic reaction. So exothermic reaction is a reaction where an heat is generated, but endothermic reaction is a reaction when heat is taken in the reaction. So reaction needs heat. So the combustion here will results in or will produce a high amount of energy. And we talked about the simplest example, which is methane. So other other alkanes, when they undergo combustion, they will have different energy from the methane, and so then the higher the energy of the reactant, the larger the heat of combustion that will be generated, and the reaction will be more exothermic. Now we reach the end of our lecture, and I split the lecture into small videos, each discussing one of the topics. So please have a look at all the videos, and if you have any question at any time, please email me.